Good morning, everybody. Today we're going to be doing the questions from the Plast 4 exams on circles. With the circle questions, you are going to look at a mixture of things. Obviously, a huge question there, 6-pointer, a 2-pointer, 4-pointer, 3, 2. So there's not a set, it's only going to be an easy question for a 1 or 2-pointer. There are some large questions in there. But what I would say is you're only going to be asked to do one of two things. And that is, you're either going to ask to be working with the circumference of a circle, which is pi times diameter. And we call it circumference. I always think it as the crust. Think of your pizza again. Food, it's the crust. It's right around the edge. It's circumference. Both crust and circumference begin with C. And so we're talking pi times diameter. If we're talking topping of our pizza, we're talking area of a circle. So when we think in area, we're thinking of all our topping, and that's not a very good circle, I know. But we're thinking area, and that's pi times radius squared. So radius times itself. We do that part first, and then we times it by pi. So they're the only two formulas that you'll be asked to remember. And once you've got the gist of those two, we can look at like the surface area of a cylinder. We look at the volume of a cylinder just by using these two parts there. Let me just literally send somebody the link for today's session. They can't get in, so I'm going to send them this, and then we'll be off again with the first question. 1 second, right. There it is. Okay, right. We're all good. That's sent, so that is good. So we're looking at either, like I said, the circumference or the area. Once you know those two, you're pretty much set for questions about circles. This one, as you can see, is a 6-pointer, so we know there's going to be more involved than just finding out the area or the circumference of a circle. So Eric wants to put rubber flooring around his shot put circle. The radius of the circle is 3.8 feet. The dimensions of the diagram are shown. Okay, so we've got feet and we've got meters straight away, so we know we're going to have to do some conversion as well. It's told us what pi is. Only use that as 3.14. You don't need to press the pi button on your calculator, because that'll give you the full-blown number. So use 3.14 all the time, and it gives you a nice rounded number, usually 3 or 4 decimal places, and it'll say to 2 decimal places. But yeah, generally pi 3.14. Use the conversion graph between feet and meters to work out the area of flooring he needs. And then we're looking at the cost of flooring online. Eric decides to use the median. So we've got a median. So first of all, we've got conversion. We've got median. And then we've got area. So we've got 3 things going on. And we're saying, is it going to be less than? So is it going to be less than? So less than 2,000 is the biggest. So is it going to be here? Is it going to be less than 2,000? We've got 6 marks to get for this one. So let's have a look. First of all, we need to look at converting 3.8 feet into meters. So we're going to go up on our graph, and I've clicked it and I've inserted it here because it says here, click on the icon below to show your graph. So that was on the exam. I've clicked on the icon, it opens it up. I've just copied and pasted and put it on here so we can see it in one. So 3.8, we're looking at each square as being 0.2. So 3.8 is right there. So we're going to go across, and I'm saying 1.12, 1.2 is there. I'm saying 1.15. So I've gone up at 3.8 here. And then I've gone along, and I think it's between those two. I don't think it's quite on the 2, and I think it's beyond the 1. So I'm saying that the radius here now is 1.15 meters. Okay, so we need to find out the orange part. He's going to put matting down. So we're going to work out the area of that first part. And we're going to do that. It's a calculator paper. As you can see down here, it's calculator paper. So we're going to go 6.5 multiplied by 5.5. We need to find everything that's in the middle. We're not walking around the outside. That's perimeter. So area is where you multiply them both together. So we're going to have 6.5 times by 5.5. And that'll give us the whole area. And then we need this area because we need to take that away. We don't need mine on there. We need it around there. So area, we've got the area here. Look, it's pi times radius squared. Pi, we know is 3.14. Times by radius, which we said is 1.15 squared. So we know now the two numbers we're going to work with, and this one will be taking that one away, wouldn't it? We're going to take that one away. So let's work out the big one first. We've got the big one. It's going to be right away, isn't it? Yep, of course. 6.5. Oh, I can make that bigger, can't I? I can put that on there. There we go, full screen. Now my calculator's bid. 6.5 multiplied by 5.5 equals 35.75. 35.75 for the full orange area, including the circle. The circle part, if we've got pi times radius squared, thinking of BIDMAS, we need to do this part first because brackets, there's no brackets. Indices, yes, that's an indices. There's a squared. So we're going to do 1.5 times 1.5 first, okay? And then we'll multiply it by 3.14. So we're going to go 1.15 times 1.15. That's our radius squared times by 3.14 equals 4.15265. 4.15625. So that's the area of where you're going to stand as a shot putter. So we're going to take away, we're going to go 35.75 minus 4.15625 equals the area we need to cover. So we're going to go 35.75 minus 4.15625 equals 31.593. 31.593. So we're going to call it 31.59 because 3 is less than 5, so it doesn't impact the number we go down. Okay, so Eric decides to use the median. So we've now done the area, what we need to put a mat on. It's 31.56. Now we're going to look at here, look, Eric decides to use the median cost per square meter. The median is the middle. So when we say median, we're thinking small, medium, and large. When we put clothes in order in a clothes shop in the morning when it's freshly opened, they're in a nice order of small, medium, and large. So we're thinking the middle value. So the middle value of all these numbers, we've got 8 values. So we need the 4th and 5th number. When there's an even number of values, we need 2. So if we just rank them rather than, we can write them here. Let's write them here. Right, so bottom one is 49.5. Then we've got, so that's that one done. 52.25, 52.25. That's that one done. 57, yeah, 57.20. That's that one done. Then we've got 2 at 58.30. 58.30. Is that right? 58.30. 58.30. Yeah. So 1, 2, 3, 4, 5. Hey, have we done all these in the right? Have we done these in the right order? Okay, let's keep working because oh, we've got 50. I missed. Okay, let's just let. Right, so we've now got 56.80. So I missed one out there. Morning, Viv. Right, 56.80 is here. So I've missed one out. Right, so 56.80 and then 58, so I've done that one. 58.30, done that one. 58.30 again, done that one. And then we've got one left at 65. I know 62, that's here, look, 62.70. I'm not doing very good at ordering my numbers today. And then 65, it's a bit tight, 90 at the end. So we need 1, 2, 3, 4. We need a 4th, and fifth numbers. If you want to check you've got the middle, we can see that there are 3 less than and 3 more than. So we need these two numbers. We need 56, 80, add 58, 30 equals, and we must divide that number by 2. We need the middle of those. So we add them both up and we divide it by 2 to find the middle value. So let's go 56.80, add 58.30 equals 115, 10, 115.1, divide it by 2, and we've now got a median cost of 57.55. That's our median cost. So he decides to use the median cost per square meter. He rounds up the area, rounds it up to the nearest whole meter. So he doesn't round it as in like go to the nearest, it's rounding it up. Okay, so that's a key word there. If we're just rounding it to the nearest, if we're rounding that to the nearest, it would still be up, wouldn't it, to 32. But if it said that was 31.293, rounding it to the nearest will be down to 31. So it's important that you've said it says rounding it up. Okay, so we've now got that would then equal 32 meters. So we've got that as a price, and we're doing it for 32 meters. And so we now need to look at the price of being less than 2,000. So times by 32 equals £1,841.60p, 1,841.60p. So our 6th mark will be, is he correct? Yes, he is. And we've shown why, because 1841 is less than 1841.60 is less than 2,000. That's the first question in circles. So that was a long one, and a 6-pointer, you're not going to get a question bigger than a 6-pointer. That is the biggest, that's the maximum amount of points you're going to get for any question on any exam with maths. Okay, Kerry buys a screen to put behind her hot tub.
But it will take a lot of time too, isn't it?
Oh yeah. For a 6-pointer, you can say, right, it's going to take me 10, 12 minutes. That's going to take me a long time. So yeah, they often have a 6-pointer. Then the next one after this in the real exam might well have been a 1-pointer, just to give you like, oh, thank goodness for that, you know, a little bit of a rest. So they don't often follow up a 6-pointer with like a 5-pointer, because that's like, that'd be too much. So yeah, often a longer question will be followed by a shorter question. Right, Kerry buys a screen to put behind her hot tub. The screen is made of a rectangle. We can see that. A rectangle, yeah. And a semicircle, we can see that. Kerry uses this formula to estimate the area of the screen. So when we're saying we're working with circles, it's not asking us to work out this as a circle, because it's giving us a separate formula here, look. So this is about order of operations. This is like using BIDMAS. And it's given us what each letter stands for. L is the length, H is the height, L again is the length, we've got a squared in there, and A is the area at the final. So if we look at this, we're going to just literally say A equals, right, L is the length, that's 4, multiplied, if they're right next door to each other, it's a multiplied by H, multiplied by 1.6. Add 3, and again, L, 3 times L is 4, and then we've got a squared, and then divide by 8. So we just converted that formula that we have to use and put in the numbers that would be where the letters are. Now we can look at it. What order do we do it in? Okay, I can see a squared there, and there's no brackets anywhere, so I don't need to do brackets. So I do the squared first. So now this becomes, yeah, indices, 3 times 4 squared. So that becomes 3 times 16. It's still divided by 8. That still says add. And now I've got 1.6 and I've got 4. Okay, so now I look at this and I think, right, I've got a multiply here and I've got a divide there. So in BIDMAS, if you have a multiply and a divide, you do them in the order you see them. So we're going to do this bit first. 4 times 1.6. So area equals 4 times 1.6. We do 4 times 16. We've got 64, so that becomes 6.4. Add 3 times 16 divided by 8. Okay, so let's scroll on a little bit. So we've got 3 times 16, 32, that's 48. So add 48 divided by 8. 48 divided by 8, that's 5. So we've just done that little bit. So in theory now we've got 6.4, add 5. That's all we've got. That's all we've got left. So from all of that, we have a simple answer of 11.4. And I'm going to double check that because that's 16. 3 times 16, 30, 42, 48. That's 48, 48. Oh, I've done it wrong. It's 6. 48 divided by 8 is not 5. That's 40. So, my goodness. Viv, you're normally on it. Right. You normally spot my mistakes. Right, so that becomes 12. Right, get my rubber on here. I didn't think it looked right. I'm thinking, why didn't it look right? Okay, so it's 12.4. Right. It's only basic timetables. Don't worry, Steve. You can't get that right. You can't get anything right. So basic timetables, my error. But then again, like I said, it just didn't look right. I'm looking at that. I'm thinking that can't be right. So when I've gone back through and worked it out again, I've recognized my own mistake. We've corrected it, and then our answer's different. So as much as if I had kept that at 11.4, I'm getting 1 mark because I've shown them the correct methodology for all of my formula, and I've done it, and I've substituted numbers in for letters. I've just made 1 mistake when it comes to accuracy. So my final answer is incorrect. However, I have shown all my workings out to be correct. So just not my mental maths here. So yeah, I'd have got 1 mark for that, not the 2. So when I've gone back and spotted my own error, I've got my 2nd mark back on track. Kerry starts to fill a hot tub up with water. The hot tub is cylindrical with an internal radius of 70 centimeters. The rate of flow of the water from her garden tap is 0.2 liters per second. Work out how long it will take the water to reach a depth of 60 centimeters. Give your answer in hours to 2 decimal places. So we've got 4 marks here. We've got pi, and it's asking us here. She's going to fill up the hot tub. Okay, not a best picture of a hot tub, I know, but she's going to fill it up to the depth of 60 centimeters. So she's going to fill it up to there. Okay, and if we could see it inside, we'd have some water there, but we don't. So when it comes to filling up a hot tub, we're looking at the, oh, where'd that go? We're looking at the volume. And if we're looking at the volume of a cylinder, we need 2 simple measurements. First of all, we need to work out the area. What's my pizza topping? We need to work out the area of the circle that's on top. Better not disappear. Multiplied by the height. So area times by height, and you've got the volume. So area of a circle, if you remember, it's pi times radius squared. And there we have it. So we've got pi times radius squared for our area of our circle, this part on top, multiplied by the height we need it for. So it's basically saying we've got a small tube of Pringles that we need filling up. So if we look at here, we've got a radius of 70. So 70 times 70 times 3.14. 70 times 70, if we do 7 times 7, that's 49. So if it's 70 times 70, we've got 4,900. Just put the 2 zeros back on. 3.14 times that. And then we're going to times it by the height we need. Okay, so we've got a whole lot going on here. If we go, where's my calculator gone? There it is. It's going to be big numbers. 3.14 times by 4,900 times by 60. Amazing. 900, right, so let's go, equals 900, rubbish at memory, 23,160. we've now worked out our volume, but in centimeters cubed. Centimeters cubed, okay, and it's saying liters. 1,000 centiliters cubed equals 1 liter. And the reason we say that, if we did it in a block, we'd have 10 along, we'd have 10 along, and we'd have 10 up. So in theory, a liter is like filling a 10 by 10 by 10 block up. And I think this question over there, I showed you a present bar. That present's gone. The dog's probably at it because it was a dog present. So every 1 liter is 1,000 centimeters cubed. So we're going to divide our number here by 1,000 because we need to know how many liters it is. So let's divide our big number by 1,000. We could just move the decimal place 3 times to the left, absolutely. But we've got the number typed in our calculator, so we'll keep it fresh. 923.16. So how do we move it from here? Look, decimal place 1, 2, 3, same number. So now we know it's liters. Okay, it fills up at 0.2 liters per second. So if we divide this number by 0.2, it's going to tell us our seconds. If you think about the whole distance, speed, time thing, we've got the whole volume here divided by the speed is going to equals the time. So if we go, our number we've got here divided by 0.2, that's seconds. Okay, so we can see it takes 4,615.8 seconds. Give your answer in hours. Okay, so if we do it in minutes first, we know that there's 60 minutes. 60 minutes in 1 hour, we know that, but there's 60 seconds equals 1 min. So we're going to divide it by 60 first, because that's going to give us our mins. And we've got our number in our calculator still here, so we divide it by 60. That's minutes, okay? So we know it's 76.93 minutes. And then give your answer in hours and then we're going to divide it by 60 again. We can see it's 76 minutes, so it's 1 hour and 16 minutes. So, but it says our answer in hours to 2 decimal places, so it doesn't want you to do it into minutes as well. So we're going to go divide that number by 60 again. And we've got 1.28. So we divide that one again by 60 to equal hours. And that is going to be, I've lost my calculator again. Where's my calculator gone? 1.28. Well, 1.282. So we got 1.282 to 2 decimal places. That is a decision maker. It's less than 5. So we remain at 1.28 hours. Had you changed it into minutes from here, you would have, again, got 3 marks because it's asking you for it in hours. It's not asking you for it in hours and minutes. It's asking you to represent it like that. So if you'd have done 1 hour, 16 minutes, you wouldn't have got that 4th mark because you've done all your workings out correctly again, and you've gone 1 step further by showing it in minutes as well, but it wants it like that because it's saying it in here to 2 decimal places in hours. It doesn't say in hours and minutes. So be mindful sometimes if you're rounding it up to minutes, does it actually want that? This question doesn't want that. Okay. Charlie will take a camping stove. The camping stove is a cylindrical bottle. Okay, we've just done a cylindrical bottle, but we've done a hot tub. The cylinder has an internal height of 40 centimeters and an internal radius of 15 centimeters. Charlie wants to work out how many hours the gas will last. He knows that 1,000 centimeters cubed of gas will last 20 hours. How many hours will the cylinder last? So it's a very, very similar question to the one above. However, one's worth 4 marks and one's worth 3 marks, which seems a bit harsh because it's asking you to do the same thing. We're asking to work out the volume of something and then the rate of how long it's going to take. We have to work out the volume of something and then the rate of how long it'll last. So again, 3 and 4 marks, generally same sort of thing in an exam. It's just a case of it's a different exam, so they might have had a spare mark to award you. So let's have a look. We've got our gas cylinder. Doing it again. We know that it's 40 here and it's 15 there.
Yes.
Radius. Okay, so we've got area times by height. And for our area, it's pi times.
So the area for a volume, it's area times height, yeah? Is that the formula?
The area of the circle, yes. So the area of one end, yeah, times by the height.
Okay.
If it was you're looking at surface area, that's something different. Yeah, there's some questions on surface area, I think, in Atom. There's some good questions on surface area. So if we're doing pi times radius squared, 15 times 15, so 15 squared times pi. Oh, I should have put 3.14 there. 3.14 times by 15 squared. So we've got 3.14 times by 225 times by 40. That's our volume. So this is our area here. Look, 3.14 times by 225. 3.14 times by 225. That's the area of your circle. And then we're going to times it by 40 for our height. And that's our volume now. So we now can see not saying a similarly large number, but we've got a large number like we had here. Once we've done the area of the circle for the hot tub and then times it by how deep we wanted it, it becomes a large number. So here we've got a gas cylinder that is the area of the circle times by the height, and that is centimeters cubed. It's asking you to work in centimeters cubed here, so that's okay now. It's saying here that for every 1,000, yeah, that's the volume. For every 1,000, we've got 20 hours. So we're going to divide this number by 1,000, not for how many hours, but for how many lots of 20 hours we need. So we're going to divide it by 1,000. We've got it on our calculator, so let's be, well, not lazy, but let's just do it while we're here rather than do the 3 decimal places to the left. So we can see that it's going to last 28 times 28.26, I think it said, of this amount.
20 hours.
So times by 20 equals the total number of hours that it's going to last. So times that by 20, and we can see it's asking you in hours, not in days. So we can see it's going to last 565 hours, 0.2. Doesn't say in minutes again, so I would keep it exactly as it says on my calculator, but make sure you don't write minutes at the end. You must put hours. It's 0.2 hours, and 0.2 of an hour is 12 minutes. But we haven't been asked to say it in minutes and hours. It just says in hours. So we're going to put 0.2, final answer, and that is that one.
That is the final answer.
That is the final answer, 565.2 hours. Yeah, done. Maybe that's why that one was a little bit more worth more, because we had to shrink the seconds into minutes and the minutes into hours. So we have to do some, you have to do more conversion, more shrinkage on that one, whereas this one was just a straight shot out from 1,000 into that one. So that was a little bit less involved. Jessica wants to put a windbreak around one side of her caravan. The windbreak is the shape of a semicircle or half circle. Caravan windbreak. Calculate the length of the windbreak. For 2 marks, the length of the windbreak. I'm seeing circumference. So I'm seeing pizza crust. So I'm seeing pi times diameter. Pizza crust all the way around. But then we've got, it's only a half a circle. So we're going to divide it by 2. Because it's only half a circle. It says half there. Okay, so we've got the diameter here. Look, it's the same as it is at the other side.
Yeah.
So we got pi times by 7.49 divided by 2. equals the length of that windbreak there. So how much does she need to buy? So that one for me, a 2-pointer, as long as you remember to divide this one by 2, that one was quite straightforward, because some people will say, oh, yeah, I know, circumference is pi times them. I've done it. So pi 3.14.
Given the fact that it's not a full circumference, it's half, isn't it?
Yeah, so we're just doing a half. So that's what we got for this part, 23.5. Oh my gosh, 23.5186. And then we're dividing it by 2. Yeah, so we want a half a circle. Divided by 2. We've got 11.759. 11.7593. It doesn't say anything here about 2 decimal place nearest meter, so I'll be tempted to say she needs 11.7593 meters. I'll be putting it as that. If it said to the nearest meter, yeah, it's 12 meters, but it doesn't say that. It just says calculate the length. It's not asking you to round it up, round it down, so I'd keep it as my full answer on my calculator. If you'd rounded it up and said 11.76, you're still going to get the mark for it, but it doesn't ask for that. So again, it's up to you. I would be tempted to keep it in my full length of my calculator, but rounding up to 11.76 isn't going to get you a mark knocked off, because they can see you've done the math, you've just rounded it up. She's gonna have a tiny little bit left over if she has that much. Last one, I think. Right, yeah. Abdul has a scale drawing of a curved edge. So very similar to what we've just had here. Curved edge. This time we're talking a driveway, not a caravan. Abdul has a scale drawing of a curved edge. This is 2.25. So this is why this one's worth more, because it's to do with scale as well. So we're having to work out what it is with using a scale, and it's a calculator paper, so we're quite safe. Right, so let's have a look. We've still got circumference. Okay, so we've still got circumference, so we've still got pi times diameter. We've got the radius. Okay, so we need to add it again. Yeah, so yeah, 2.25 add 2.25 equals 4.5. So we know the diameter is just 2 lots of the radius. So we're going to go pi times 4.5 equals there. It's a semicircle, so it's a half circle again. So we're going to divide our answer by 2. Okay, so we're going to go 3.14 times 4.5 equals 14.13. 14.13 divided by 2 equals 7.065. 7.065. Right, this is where we now need to look at our scale, because it's saying here for every 1 centimeter, that's the same as saying 200. So that's the map. That's real life. Okay, so we've got, on our map, we've got 7.065. So to get from this number to that number, we've multiplied it by 7.065. So we need to do the same for this one, times by 7.065, because we're stepping them both up by the same amount. So on our scale, we're going to times that one by 200. And we've got the length in in centimeters. Is that in centimeters? My brain's not thinking straight now. Scale is 1 centimeter for 200. Okay, so that's what we're buying. We're buying it in that. So that's why it's worth more. So we know it's 1,413 centimeters. That's how far our garden edge needs. We can see that each strip is 250 millimeters. So we know there's 10 millimeters in 1 centimeter. So we're going to divide that number by 10 to get it into centimeters. So we can see that each one of our strips is 25 centimeters long. Now we've got them both in centimeters. We've got our length of our garden, whatever it's called, the edge, and we've got our length of our strips that go along the outside. So we're going to go 1,413. That's our garden, divided by the length of each strip, which is going to give us the number of strips that we need. So let's do that. Divided by 25 equals 56.52. Equals 56.52. Right, your professional issues that thinks it needs more than. So the answer isn't the nearest strip how many we'll need. He said he's going to need more than 60. So 60, he thinks he needs more than. We can clearly see that our 56.52 is less than. So Abdul is incorrect. Abdul, incorrect. Because we've shown why. We've seen that we've done all the workings out. He needs 56.52, so he needs 57 maximum. And so it's still less than 60. Okie dokie. That is the last question. Let me stop sharing. Let me stop recording. And then, so